So I want to demonstrate the faster modes for iScaf 11 for shaded fast mode and wireframe fast mode. I'm first going to show you the accelerated modes using inbuilt AMD graphics in a Ryzen CPU. It's actually a 7950, but it's the same Radeon in all the 7000 series, I believe. So we've got a massive drawing here, 50 meters by 50 meters by 50 meters high, of Kwikstage that has nearly 40,000 3D parts in it. And I'm just using this very low included CPU at the moment. So zoom's quite slow, takes about a second or two to zoom in and out on. But once we reach our zoom position, in shaded fast mode here, rotation is actually quite quick, and we're getting probably around about maybe 15 to 20 frames on such a massive drawing. It's pretty large improvement in performance, and when we release it takes a little while to recover. You can see down here that the AMD graphics built into the CPU is being utilized in performing these 3D feats. I'm going to keep this drawing loaded, and I'm going to turn off the graphics performance options. Okay, so you can see this fast shaded mode currently enabled. I'm going to turn off all hardware acceleration. So it's not going to be using the CPU, it's just going to be using the GPU, it's just going to be using the CPU. And it's going to recompute. Now it's going to take some time to recompute because it's not got the GPU to help it compute all the vertices of 40,000 pieces of equipment. And you'll see this fast mode for shaded disappear once it's managed to refresh. So the CPU is quite fast, so there's a limitation that even though the CPU has 16 cores, it's only using one of those to compute the majority of the information. Okay, so you can see now we've got shaded mode, fast no longer selected, so I'm going to zoom in, and the time to zoom in takes around about the same amount of time. And now I'm going to do an orbit, and you'll see the difference is that it is unable to keep up, so it's just doing a minimal refresh. I'm letting go of my button, I've stopped scrolling, but because the system has rotation cached, it's going to continue on. So this can take like 30 seconds for the system to finish what it's doing and get to the location that it's getting to, which is not really ideal. And you can see in this 3D mode, there's no 3D compute going on with the inbuilt AMD graphics. So you can see it's substantially slower, and 2D wireframe is similar sort of speed. So once again, this drawing does have 40,000 highly detailed 3D elements in it, so it is a very, very large drawing, just to demonstrate the differences that you can expect from iScaf 11 fast mode if you have supported 3D graphics. And it appears that the Intel Arc cards are not currently supported for acceleration in this mode, but the current crop of or for the last few generations of AMD and NVIDIA GPUs, even the gaming ones, are supported. So this is all running on a desktop machine rather than a laptop. The NVIDIA cards in particular, they have the same graphics card names for their laptop version and their desktop version, but even though they have the same name, an RTX 4080 for instance on a laptop, performs about the same as a 4060 Ti on a desktop, even though the names are exactly the same, or if you have a 4080 desktop compared to a 4080 laptop, the 4080 desktop will run about 3 times faster. It's still catching up to where this display is going to be, so you can see that this mode is changed. Once this finishes and restores, I'm going to change my graphics card over for a desktop 4080 Super, which is quite a high-end card. Cost me about $1,500 6 months ago. You can't get them anymore. The 5000 series has gotten much more expensive, so you might be able to find something on a second-hand market that might help you out. But you can get quite good results with relatively low. So have a look at the recommended devices on our website to make sure that you have hardware that can fully take advantage of this. But even if you do have just inbuilt graphics on your CPU, you will still see a substantial improvement in performance in 3D fast modes, which is the wireframe fast and the shaded fast modes. So you can see we've just finished there. Okay, I'm just going to break here and I'll come back and load in the 4080 Super so you can see how fast that is in comparison. Okay, so I've loaded the same drawing back in. This time the graphics card that is connected is RTX 4080 Super NVIDIA card on a desktop, which is not the same as a 4080 laptop, just to be clear. So the zoom, just zooming in, is around about the same sort of performance. But when you finish doing your zoom level, if you start your orbit command, you can see that the performance of this card, you can't kind of get it to slow down. It's very, very fast. So I'll zoom in again. Change my perspective. Slight pause. Pans immediate. Every time you stop, and slight pause. I'm just going to zoom in on a window. And from this direction, we'll orbit. You can see there is substantial improvement in the speed for iScaf 11 using an advanced GPU. Cheers. So I have a different drawing here, just probably more typical of standard small residential to medium commercial type drawings. It's got 4,500 parts in it and 51 tonne. It's got the same module. There's a few extra features in this one. We are using the GeForce 4080 Super again to have a look at this. So this is a desktop version, and this one has sort of a little bit of sloping ground and that sort of stuff in it as well. So you can see other features and whatever, and you can see that this performance on the 4080 is unchanged. It's very, very rapid. Probably managing anywhere in the order of about 120 frames a second. And it's not even really taxing the GPU. So I'll come back to you and I'll show you what the onboard AMD software does with it. Okay, so we've got the Radeon Graphics in use now, and we've loaded in the same drawing. And you can see the fast shaded mode is enabled, and you can see that the performance with this drawing is, it's not quite as rapid, probably getting about 30-40 frames a minute. So onboard AMD graphics with modern AMD Ryzen 79 series, 7000, 9000 series are actually working quite well. We'll try to the Intel Arc graphics next, because that has been having some issues. One moment. Okay, so this is the Intel Arc A750 graphics. It's a separate graphics card. It's not onboard graphics, but we found lately, for the last several versions, the DirectX 12 support of the Intel onboard graphics and Intel Arc graphics has not been passing the FP64 mode, so fast shaded cannot be enabled on these cards. So their performance, therefore, is going back to normal type behavior. So it will still use some acceleration, but these fast modes, which you'll see in the orbit, are quite a lot slower. Now it is managing on this smaller drawing to work reasonably well and use some of the GPU you can see on there on the side, but it's producing probably around about 20 frames on this smaller one. But I'll reload that 50-50-50 on the Arc, and you'll see that it's substantially slower. Okay, so we're using the Intel Arc to render this in iScaf 11. This drawing has 500 tonne and 40,000 parts in the drawing, and you'll see that the orbit using the Intel Arc, it degrades and can take quite a long time to repeat. I've let go of the mouse button and it's catching up. Not quite as slow as one of the other ones. Zooming with this many objects is also quite a lot slower. The 4080 desktop is very good at performing the calculations required to recompute the vertices, which is what's going on here. But as for actual 3D acceleration of this mode, the Intel Arc and the onboard Intel graphics, apart from some very recent ones that have not been enough for us to be confident going forward that's where it's going to remain, just be aware that these 3D accelerated for onboard Intel graphics and Intel Arc are probably not going to work. Intel Arc B series might be a different story, the Battle Mage, but as I said, we haven't been able to secure access to enough of them to be sure that we can confidently say they're okay. All right, I'll go and do some desktop laptop versions of the same thing now, and we'll be back shortly. So I am on a laptop now, and if we just have a look on here. So this is a Intel laptop. It's part of the Intel NUC series. It is an 11th gen 11800H with 16 cores, and has an embedded display device as well as an RTX 3060. So it has the Intel onboard graphics, which is common to a lot of recent Intel displays, as well as having an RTX 3060 laptop GPU. Bearing in mind that the laptop GPUs have substantially less power than their desktop counterparts, even though they have the same name. Okay, so we've just got the Intel UHD graphics on here at the moment, engaged with iScaf. You can see the fast shaded mode again is being disabled, same as the Intel Arc. So the onboard Intel UHD as well has the same problem. Don't have little faded fast suffix on the shaded option there. And when we do our orbit, you can see that it's substantially slower again. So you can see that all the elements here are quite a lot slower. Okay. And I'll show you the 50-50-50 as well. Just one moment. Okay, so we are back with our Intel onboard mobile laptop graphics with a 50-50-50 drawing, 50 meters square and 50 meters high. And we'll go in and start rotating this one. You'll see that the Intel UHD onboard graphics is still doing a passable job, to be perfectly honest, with something this size. It's a high-performing CPU as well. It takes a little while to recover from doing, but there's no fast shading mode involved with this. But it's still not performing terribly bad, just compared to the accelerated 3Ds. They are not as good. So let's change to the onboard RTX 3050 laptop and show you what these look like in that. Okay, so we've engaged the NVIDIA RTX 3060 laptop GPU now, which has fast shaded node support. And you can see that the GPU here is just got its performance, so we just turn it. So zooming with this number of vertices, just like in the other, is a bit slower, but the rotation is quite good. So you can see this is nearly as good as the 4080, although we're saturating the GPU a lot more doing these drawings. Let go. Has to recompute and recompute and regen. So just zoom in. You can see that the zoom in is probably more to do with the CPU and somewhat to the GPU. Okay, and I'll stop doing that, and then you can see that its performance here is quite good as well in 3D. So if you get even just this is not by any means a high performing laptop GPU. It's on the lower tier, not quite the lowest, but yes, you can get quite good out of moderate, like 2000 2060s be quite good in the laptop space as well. And also, once again, bear in mind that the 3060 desktop GPUs are roughly about 50 to 80% faster than the laptop ones that have exactly the same name. It's a bit of a bugbear of mine. It's a bit of stupid naming, but anyway. Okay. And I think we've got one last round of test to show you. Okay, so I'm running on a relatively recent laptop's a couple of years old now in 2025. It's a Ryzen 7 7745HX with inbuilt Radeon graphics. They're UHD 610M, Radeon 610Ms. So it's their more basic versions of the graphics that they usually bundle with their CPUs that are inbuilt with them. And this particular laptop also has a NVIDIA RTX 4060. So it's kind of on the same tier as the 3060, a little bit faster, a little later. Mind you, the 5060 is not as good performance-wise generation on generation. So just a bit of extra information there. So you can see it's doing some 3D work in the background. It's probably because I'm doing the recording. It's using that to do it. Okay, so this is our standard test drawing. As you can see, the response here is quite good, getting about 60 frames, maybe even more on this drawing. Zoom for this smaller drawing is quite good. But yeah, you can see the performance using the inbuilt AMD is quite good. the very busy, sorry, it's very windy here today. Very busy, the CPUs that are more recently being released by AMD are beginning to integrate some quite advanced graphics, which you should see quite substantial improvements on, that use the RDNA GPU structure built into the CPU, and they should be well capable of doing some extremely good performance without breaking the bank. All right, I'll swap over to the 50-50-50 with a 610M. Back in a moment. Okay, so we've loaded the 50,000 item 500,000 tonne model in, and let's see how we perform here. So this is in fast shaded mode using the inbuilt AMD Radeon 610M. As I said, there's new AMD Radeon laptop CPUs that are coming out with RDNA graphics enabled in them, and they're substantially faster than this, without requiring maybe an external graphics card. So we're just getting some delays in compute to zoom in and out on such a large model, but we'll see if that improves when we engage the external graphics card. Okay, I'll come back with that in a sec. Okay, so I'm back now with the NVIDIA GeForce 4060 laptop GPU, which has 8 gig of video RAM. You can see fast shaded mode is enabled here. So this is on our big drawing with 500 tonne. You can see that the performance in this drawing for a movement perspective is quite high. Again, like earlier, mentioned that there's a lot of CPU usage in changing zoom, so configuring all the vertices, of which there's well over 8 million for every view change in this drawing, to zoom in and out. But again, as you can see, you can really get, and I can't get the GPU to be saturated on this for performance with such a complex drawing. And lastly, we'll just show you the 4060 with the smaller medium commercial. So using the RTX 4060 laptop with 8 gig of video RAM with the medium level drawing. As you can see that we can't get this one to slow down. Its performance is quite good. It's able to zoom in and out a bit faster just because the sheer number of elements in the drawing is less. You can use isolate objects to limit the amount of objects that are being drawn in iScaf for larger drawings so that you get better performance. That's sort of advanced, and there's some other advanced shading modes here. So if I just move this out of the way, there's a 3D wireframe is also fully accelerated. So I can't get this one. Still getting 60 odd frames and not really slowing it down. The 2D wireframe though goes back to using the CPU only. So the zoom's a little bit faster and a bit less memory to move around. But yeah, that's all working fine too. All right, I think we're done.